right, here we're going to take a look at problem number 24. Which in your setup, we take a look. There are two forces, F1 and F2, and these are shown in figure 4-43A and B. So 4-43A looks like this. You have a y-axis and an x-axis. Sorry. And we experience a free body diagram where force 1 happens in the negative x direction and is separated by a 90-degree angle from force 2. And we need to find the net force of the object and the acceleration. So we're trying to find the net force and acceleration of these two objects if the value of F1 is 10.2 newtons and if the value of F2 is 16.0 newtons. So that means that we need to figure out what the resultant vector of these two are, and if we have that resultant vector, we need to figure out the acceleration. And this is A. Part B, here you have an axis where this is your y and this is your x, and you have the object which is experiencing F2 along the y-axis, but actually F1 here is separated by 120 degrees from F2. So again, you're trying to find the sum of these two forces and the acceleration of these forces. And again, for this one, F1 is 10.2 newtons and F2 is 16.2 newtons. And one thing I can give you a hint for part B, you know that when you set your axes, that the y-axis must always be perpendicular to the x-axis. You also know that when you're resolving vectors to find the net force and you have something happening in two different directions, that you need to break things down into the x and the y component, and that you need to make sure to always establish. So we'll establish here, this is a positive x, this is a negative x, this is a positive y, this is a negative y. And we'll do the same here where this is a positive y, this is a positive x. And that should help you resolve for the net force and the acceleration.